Okay. Hi, everybody. I'm going to talk about how to make your library OSGi-friendly without depending on OSGi. There has been a lot of talk at the conference, particularly on Monday, about modularity. I think I'm one of the few speakers to actually use the word OSGi in a title, and I've been brave enough to use it twice, and I'm glad that hasn't scared you lot off. My target audience for this talk is you're a Java library author. You're writing libraries, and you would like those libraries to be widely used. I mean, wouldn't we all? That's why we write libraries and release them in open source. And you want them to be used by OSGi users, because that's an increasing population of Java developers are using OSGi. But you also still want it to be compatible with non-OSGi users, so you don't want to depend on OSGi. So I'm sure some of you will be familiar with Ubuntu Bug number 1. So this is bug number 1 in the Ubuntu Launchpad database. And the bug is proprietary operating systems, such as Windows and macOS, have a majority market share. That's the bug that Ubuntu set out to fix. Well, OSGi has a bug as well. OSGi bug number 1 is that some Java developers, I've heard, are still not using OSGi. Not yet, at least. And some Java libraries out there are violating modular principles. They're not just violating rules that we put into OSGi just for the sake of it, but they're violating real modular principles. And by the way, those libraries are going to break when Jigsaw comes along, if Jigsaw comes along. So kind of stop blaming OSGi and start looking at the violation of modular principles that is happening in some of these libraries, because it's going to cause a problem in the future. So in Java, we have the class path. Well, no, we don't. This is going away. The class path is over. It is gone. There is no such thing as a class path. This is true in OSGi. This is going to be true in Jigsaw. So what do we do? In Java, the identity of a class is a combination of two things. It is the name of the class, the fully qualified name of the class, and it is the class loader that loaded it. Even if you load exactly the same class from the same bytes on the disk in a different class loader, then it is a different class. And in a modular system, this means that the class identity tends to be the class name plus the module that it comes from. So if you have some code that does this, class.forName org.example foo, well, I have 4 org.example foos in this system. Which one do we choose? Basically, when I do the call at the top, it's pretty much unpredictable which one of these I'm going to get. So why do people use class loading like this? There are some uses and some abuses of class loaders in Java. A very common use is as an extension framework, a kind of a poor man's extension framework. Now, in OSGi, I'd like to do many of these extension framework kind of things with services, but that does kind of imply a dependency on OSGi. So it is kind of valid to do this, but we need to do it in the right way. An example of an extension framework is like log4j appenders. You give it the name of an appender class in your configuration for log4j. It loads that appender. Another use is mapping data to objects, like Hibernate maps domain classes to database records. And then the third way that people use classes is as a kind of lazy initialization, like a poor man's factory. You know, with Jigsaw, you have a per request instantiation of the resource class, so you give it the class instead of an object. So there are various ways of doing this. The first one, class.forName, is bad because it assumes which class loader is going to come from. It doesn't specify which class loader, and therefore which module, this class is going to come from. Therefore, that is bad. The second version of this call does specify that. It's the 3-arg version of class.forName. Unfortunately, this also does some caching of the result in the calling code, which causes some additional problems. And so the good way of doing this is classLoader.loadClass. And you notice this is not a static method. So you have to have an instance of classLoader to do this. So you have to specify which class loader the class is going to come from. And then the really, really bad way, the oh my god, what the, yes, is going to this insane thing called the thread context class loader, which I don't have time to go into details of. A question to ask is, actually, do you even need a class? I mean, Java is an object-oriented language. Why can't I just give you an object? Can't I give you an appender? If I can instantiate as the application, I can give you an appender. But assuming that you really do need a class, always allow the client of your library to specify the class loader, to pass in the class loader. Because the client of your library knows the context, it knows the construction of the application, and it almost certainly knows where to get that class from. You, the library, do not know that. Another way you can do it is allow it to pass in a Java lang class object rather than a string, because that will allow us to, rather than flailing about trying to guess where this class is, it actually gives us the class. And you can still fall back to sort of heuristics like class load, your own class loader or the TCCL as a last resort. But whatever you do, document your solution so that somebody who's trying to make this work in OSGi can work out how to do it. Okay, next big area that causes problem is the service loader. Service loader introduced at least in a standard way in Java 6, and it's a kind of okay idea, but it's a shame about the implementation. A lot of things are like that in Java. And it's based on scanning the class path. Yeah, the class path that doesn't exist. The other problem with the service loader is that it's in java.util. So it's in the boot class loader. There's no way in my application I can override what service loader.load actually does. In OSGi, when we see this, we actually have a little thing that will do bytecode replacement to fix those calls to service loader.load, if we have to do that. So what if I want to load services without directly calling service loader.load? Well, dependency injection is your friend, and there's also this thing called OSGi Connect implemented by PojoSR, which is actually the OSGi service registry without the OSGi module layer. So it's a nice, easy way to get into OSGi without having to do the full modularity at that stage. Here's just an illustration of actually what's going to happen if you use service loader. You know, I'll just see the classes within one module. I won't see all the other classes. Dynamics, and who wants to live forever? Java library authors tend to think that their library lives forever, or at least for as long as the JVM is alive, which is pretty much the same thing. So the JVM lives for that amount of time, and the library lives for maybe just a bit less until the end of the JVM. Well, in reality, your library may be started up for a short period of time and then stopped, and then maybe started again later. And this can cause all kinds of problems if you don't clean up after yourself. So you really need to make sure that your library has a way to stop and clean up all those threads, all those streams, sockets, windows, everything else that doesn't get automatically garbage collected in Java. And be very careful with these kind of memory leaky patterns like observable pattern. And please, please, please die nicely when the client application tells you to die. Configuration. Where is my library going to load configuration from? Well, an all too common answer is, well, let's create a configuration location, $home/.myjunk directory, and I can put anything I like in there. Well, that's fine for one library, but then my entire application has got 20 different configuration files in 20 locations and different formats, including XML and JSON and properties, whatever else. How am I going to dynamically change the configuration if my application needs to do that? And then there's other questions. Well, what if there's no file system? What if I'm running on a device that doesn't have a file system? Java does support that. This library doesn't. Another all too common answer is system properties. -d something, -d something else, and all this goes on the command line. Now, what is a system property? A system property is nothing but a global variable. And I don't think it takes a genius to work out that a global variable is bad for modularity. The other problem with this, of course, is that when you write out your command line, it can be huge. It's like typing out War and Peace every time you start up a server. So, suggestions. The library needs to cooperate with whatever the client application wants to do. But the library doesn't know what the client library wants to do about configuration, so it really, really has to be programmatic configuration. Libraries must support programmatic configuration. And maybe they can fall back to some file. Again, an example, logback. Expect a logback.configuration file on the class path. Again, the class path that doesn't exist. So you can use some of these kind of legacy mechanisms as your fallback, but always allow programmatic configuration to override that stuff. Stop making assumptions. Java libraries can't assume what kind of context they're running in. They want a class, and they go and try to load the class loader. They do it with the class.4name with a single argument. They're making an assumption that that class is visible on that particular class loader, and that may not be true. Some of them go through a whole series of heuristics. They try their own class loader. They try the thread context class loader. They try some other kind of class loader. And then they compare the results. The problem is that every library does it slightly differently. If I just allow my client to drive that, and because I know what the context is, if I just allow my client to drive that, then they can be compatible with OSGi. Don't expect to live forever. Make sure your library can start and stop cleanly, as many times as I want to do it. And don't make assumptions about the configuration of the application, where to find the configuration, what format it is in, whether there's even a file system or whatever. Again, let the client tell you. So what I'm really driving at here is there's two abbreviations, one that I'd like to kind of coin here. The first one you probably already know, keep it simple, stupid. Don't do lots of complicated stuff, especially with class loaders, because it just may not work. It may not work in OSGi, it may not work in Jigsaw, it may not work on certain J2EE servers. And in fact, people still have problems today with that kind of thing. And the one that I'd like to coin is Yannick, which is you're not in charge. You're a library author. You're not in charge. Get used to it. The application developer is the one who's in charge and is going to tell you where the configuration is, where the classes are, what services are available, which they can do via dependency injection. So yeah, that's it for me. Thank you very much. Any questions? Wow. Nothing at all. I was that comprehensive and covered all questions. Yes. Yeah, so there are a lot of legacy libraries that have these kinds of issues, right? So a lot of the time you can make quite small incremental changes. You just need to add an additional bit of API that says, you know, when I load this thing, here's the class loader as well. Add an additional method. That's all you need to provide. So skip the bit that searches for a class loader. I did something like back in 2005 with Spring in OSGi, way before sort of Spring DM happened and all that kind of stuff. And it was very easy because Spring has always provided an API call that says, load that application context from that XML file, which contains class names in an XML file. That's kind of the problem. But they always provided an API call that said, here's the class loader. And so I could pass the class loader, and it was no problem. Hibernate is much harder because Hibernate doesn't provide that, or did not provide that method to set the class loader. So there are relatively small changes you can make to legacy libraries to allow it to conform to these rules. And it's just a first step rather than saying replace the entire system of configuration. Any other questions? Okay. Well, thank you.